Let's look at some homework problems involving integration by parts. This is section 8.2. Um, so number 11, we have integral of x times e to the negative 2x dx. We should always be checking for u substitution first before integration by parts. But because it's integration by parts, we know that most of the problems will fall under this category. But let's go ahead and do that check anyways. If we let our u value be negative 2x, our derivative will simply be negative 2, which will not cancel out with this x, and that will allow us to not be able to continue with the problem. So u substitution is going to fail in this instance for number 11. Okay, so we go and look to integration by parts. We compare x with e to the negative 2x. We have a algebraic versus a exponential function. So algebraic or polynomial will take precedence over exponential. So we let our u value be x, derivative is 1. Our dv is e to the negative 2x. So if we want to find the integral of e to the negative 2x, we have to go through u substitution. And if we do that, we can let the u value be negative 2x. Our derivative is negative 2. Our dx is du over negative 2. And an integral of e to the u times du over negative 2, it'll produce a negative 1/2. So you can actually see that there's a pattern. Anytime we're taking the integral of a function with a u value being a u value being a negative 2x or any type of coefficient in front of a variable, it's always going to come out as the reciprocal of it once it gets pulled out as a coefficient. So that's just another thing to keep in mind, especially if we're going through tab method, having to go through this multiple times. You can see that a pattern is going to develop. But here we have integral of, we are left with u times v minus integral of v du. And this combines to be negative 1/2 x e to negative 2x. And we have negative the integral of negative 1/2 e to negative 2x dx. And this basically requires another set of u substitution. But we've already seen that this negative 2x will produce a negative 1/2 as a coefficient. And so if it produces another negative 1/2, negative 1/2 times negative 1/2 will give us a positive 1/4. But then there's another negative here. So then we say negative 1/4 e to negative 2x plus c. I'm not going through u substitution again because I've already done all the work here. I'm just pulling out the fact that I know I'm going to produce a negative 1/2 every time I find the integral of e to negative 2x. Okay, number 13. I have integral of x cubed e to the x. Okay. X cubed, this is a degree higher than 1. And I can go through tab method because, first of all, u substitution is not going to work. No u value will allow us to cancel out the other variable. And so also we go through our acronym preference order, and we see that our polynomial will beat out the exponential function. So I'm going to go through tab method here, which would be more efficient. So x cubed is the u value, e to the x is dv. And then we go through and we find the derivative until we get to 0. And then on the right side, we can find the integral of e to the x. The nice thing here is that this x will only produce a 1 as a coefficient, so there's not going to be anything that will be produced more than a 1, unlike the previous problem where there's a negative 2x. Okay. We start off with a positive and we assign alternating signs. And we draw an arrow matching up the diagonals. This shows us which terms we're going to be combining together. And then we combine all the terms together. And I just went ahead and I also just knew that e to the x is in every term, so I factored that out. And then finally plus c. Okay, 15 is actually a little different. We're going to go through u substitution first. And if we think ahead, if we let our u value be x cubed, our derivative will be 3x squared, and 3x squared will be able to cancel out this x squared. So this shows us that 15 is actually a u substitution problem that was mixed in with this homework section. So our u value is x cubed to the x to the third. We're going to go through u substitution. X cubed becomes 3x squared. We solve for dx, so dx is du over 3x squared. Remember, with u substitution, we're trying to replace everything in terms of u and be left with something that we can have a rule for. Okay, so the x squared stays initially. E to the u, x cubed gets replaced with u. Dx gets replaced with du over 3x squared. And then the x squared cancels out nicely. 3 is a coefficient that we can pull out in front. And then we're left with integral of e to the u du. And we know there's a rule for e to the u, which is simply e to the u plus c. So we found our integral and replace our u value back in terms of x. Okay, let's continue looking at some more homework problems. This is number 17. We have the integral of t, natural log of t plus 1 dt. Going through our acronym preference, we see that we have a algebraic versus a log. So log always takes first precedence. So we have u being natural log of t plus 1. Okay, the reason why logs always come first and inverse trig is because we don't have integral rules for these two types of functions. So that's why we can never put logs or inverse trig, inverse trig, as dv, because we'll be stuck not having a rule to available to us to use. So our u value is natural log t plus 1, and so our dv is t dt. We find the derivative of natural log, which is 1 over t plus 1. The integral of t, we go through power rule, so t squared over 2. Okay, we plug into our formula, uv minus integral of v du, so u times v, that's given here, minus the integral of v times du. Now, if we combine this together, we're going to get t squared over t plus 1. We can pull the 1/2 out as a coefficient. And this problem, we actually have to go through synthetic division. Okay, it's a little messy here. So synthetic division says that we can take out the constant for the divisor. And we take the opposite value of that. And then we go down and we write the coefficient of each of our term in the dividend. So t squared, the coefficient is 1. And then we have also, we're going to have to include values, coefficients until we reach to our constant. So t squared, so 1t squared plus 0t plus 0. And we bring the 1 down, multiply the divisor here. Negative 1 times 1 is negative 1. We add with the term above, so 0 minus 1 is negative 1. Negative 1 times negative 1 is positive 1. 0 plus 1 is 1. And then this represents our quotient. And so we have to assign variable with degree 1 less. So t squared becomes 1t minus 1 plus, and then this is our remainder, so 1 over t plus 1. And then once we have that, we have each term separated by plus or minus. We can treat each like a separate problem. Both of these we can go through power rule, and then this is a natural log rule. So we have t squared over 2 minus t plus natural log of t plus 1. And so all this is coming from this integral portion of the integration by parts. And that means we have to make sure we don't forget this u times v as part of our final solution. So we bring that down, minus the result of the integral of u dv, integral of v du, and then we finally have plus c. All right, number 19, we have the integral of natural log quantity squared over x dx. This is also a problem that we have to go through our checklist order, and u substitution is actually going to be the appropriate rule here. So if we let the u value be natural log of x, we can actually eventually help cancel out this x and leave us with a problem where we can apply power rule. So u is natural log of x. Our derivative is 1 over x dx. So dx is x du. So we want to make a substitution for natural log of x, replace dx, and see if we can find a way to get that x to cancel out. So natural log of x gets replaced with u, so u squared. over x, that'll stay initially. Dx, okay, dx gets replaced with x du. The x's cancel out, so we're left with integral of u squared du, and this is simply a power rule, u cubed over 3 plus c, and then replace our u value back in terms of the original variable, so 1/3. I'm going to pull that 3 out as 1/3. 1/3 natural log quantity, natural log of x quantity cubed plus c. Okay, one more here. 23, we have integral of x squared minus 1 times e to the x. If we try and go through u substitution, we're going to see that if we let our u value be x squared minus 1, it won't cancel out the e to the x. If we let the u value be e to the x or x, it won't cancel out the x squared minus 1. So now we're going to look to integration by parts. X squared minus 1, we can treat this like the algebraic portion, e to the x. We can treat this as the trig portion. And so we can actually go through tab method because we can assign the u value to be the algebraic portion, in this case x squared minus 1. So x squared minus 1 under u, dv is e to the x. So we go through derivative, x squared minus 1 becomes 2x, 2x becomes 2, 2 goes to 0. And then the integral of e to the x is convenient, it'll just be e to the x. Okay, start with a plus, and we alternate signs. Multiply diagonally, and then we're going to be left with e to the x times x squared minus 1 minus 2x plus 2. So all I'm doing is just pulling out the e to the x as a common factor, and then combining the rest of the terms. And we can actually combine these like terms and eventually factor out to be x minus 1 quantity squared.